Aggressive tumor cells are defined by the rapid, unchecked division. To sustain this continuous multiplication, they require a massive and constant supply of structural resources to build new genetic material. One of those crucial resources is uracil. Uracil is a naturally occurring nucleobase that forms the foundational architecture of RNA, making it strictly required for cells to transmit genetic information and replicate. Looking at this side-by-side molecular schematic, we can observe normal uracil on the left and 5-fluorouracil on the right. 5-fluorouracil, or 5-FU, is a synthesized chemotherapy medication. As the diagram highlights, its physical structure is nearly identical to native uracil, with the sole exception of a single strategically placed fluorine atom. This exact structural similarity makes 5-FU an antimetabolite. An antimetabolite is a chemical that closely resembles an essential cellular substance, allowing it to enter biological processes undetected and sabotage them from the inside. The structure itself is an intentional disguise. The lethal efficacy of this drug relies entirely on molecular deception. By sneaking a sabotaged building block into the cell's foundation, the treatment turns the tumor's massive resource demands against it. To understand how the sabotage executes, we must look at the S phase of the cell cycle. The S phase, or synthesis phase, is the specific window in the cellular division process where a cell actively duplicates its DNA. During this synthesis window, the cell operates under severe time constraints and urgently requires a massive influx of a specific nucleotide called thymidine. Thymidine is a unique building block strictly required to construct new, stable DNA strands. In this abstract representation, we see thymidylate synthase, or TS. TS is the specialized manufacturing enzyme responsible for chemically converting uracil-based precursors into that essential thymidine. Without the TS enzyme functioning, thymidine production stops. 5-FU acts as a pyrimidine antagonist. A pyrimidine antagonist is a drug that specifically competes with natural biological molecules to bind with and neutralize their targeted enzymes. Because of its disguise, 5-FU beats normal uracil to the TS enzyme, blocking the receptor pocket completely. By targeting the distinct temporal window of the S phase and neutralizing a single specific enzyme, 5-FU forces the most aggressive, fast-growing tumors to effectively poison their own supply lines. The moment 5-FU successfully inhibits the TS enzyme, the cellular manufacturing process experiences an immediate, hard operational halt. Because the conversion mechanism is jammed by the decoy molecule, the downstream biochemical deficit